there, welcome to another college mathematics video. In this video, we're going to start to take a look at our unit on geometry. In this section in particular, we'll get a lot of the really basic kind of building blocks for what will ultimately lead to the more hands-on stuff in geometry. So our objectives for this video are to look at vocab for points, lines, planes, and angles. It's often the case that the first section is filled with vocab. We're going to classify angles, we'll find complements and supplements, and then solve problems. Okay, so our notes. The first definition we have is on a point. This is an element of some set called a space. So you can imagine a point if you've ever done any sort of graphing on the XY plane. We're not doing that, but that's what you can picture. You would draw one little point. It could exist somewhere here. That point doesn't necessarily need to be a two-dimensional space. For the time being, it will be, but it could also exist as a three-dimensional spot. Here it is right there, something like that. The next definition we have is for a line. This is a set of points. So a bunch of points make up a line. You can imagine if this is the line, a line isn't necessarily fully connected fluid all the time. It looks that way because there are millions and millions of points so close together that it looks like they're overlapping. If you were to zoom in really, really close, almost like if you were zooming in on like an atom, you can see the differentiation. Typically, we don't think of it that way. We think of the line as being connected. But technically, a line is made up of lots and lots and lots and lots of points connecting together, going off in both directions forever. Okay, our next definition is for a plane. This is a flat two-dimensional surface that extends infinitely far. So you can picture the screen that you're looking at right now. If you pictured it going out to the left and right, up, top and bottom forever. Now you're only seeing a slice of that two-dimensional surface that goes forever. It could be crooked. If you imagine paper, that paper could be sideways, something like this, forever and ever. That's a plane. Then we have, and the truth is a bunch of lines make up a plane. So if you imagine we had, here's a line, and here's a line, and here's a line, over and over and over and over and over and over and over. It gets more and more dense the same way that the dots connect to make a line, giving you that flat two-dimensional surface. Our next definition, array. This is a line that starts at one point and continues in one direction. A little different than a line because it starts in one spot and goes on in only one direction. And then an angle is a union of two rays with a common endpoint. So here's the endpoint. Let's say this is one of the rays. Here's the other of the rays. This space right here creates an angle. Technically, you could also look at the outside as creating an angle. And if you were to continue on, maybe into trigonometry, you would see that. But in this class, it's not something that we're going to worry about. So typically, it'll just be this smaller angle that is created in between them. So there's our definitions. A few more notes. It's a little bit more drawing to do here. We have angles. Some of them are named, some of them are not. So you can quiz yourself and see there are 4 different types of angles that you could see. See if you remember any of them. The first one, and the order in which you list them doesn't make any difference. The first one that I've drawn right here, maybe now that you're seeing it, this little box in the corner tells you that it is this special angle. This is a right angle. And what makes it a right angle, what makes it special, I'm going to label that the angle created here is x, is that it is a 90-degree angle. That little circle up top is for degrees. Okay, the second type of angle that we have, union, two rays, a small angle, is called an acute angle. Easy to remember, acute, because it's cute and little. And what's true about the angle measure there is that it's less than 90, but also greater than 0. Technicality, most people would say less than 90, and we would understand what you mean, but technically it wouldn't be a negative number. Negative angles do exist. It's not a thing that we'll see in this class, though. Okay, the third type of angle that you will see is, so we have the right angle, we have smaller than right, this one's bigger than right. Again, we'll say the angle measure here. This one is an obtuse angle. And an obtuse angle, most people would say, is greater than 90, but again, we have to put in that other caveat. It's also less than 180 degrees. So 180 would be right here. It doesn't go further. We're not going to look at that in this class. And then the last one, which I imagine would be the most difficult to come up with because you don't think of this as an angle, but you could look at it that way. If this is your common endpoint and the rays go out exactly opposite of each other, then you have a straight line. And in that case, x is equal to 180. So every potential angle we'll see in this class can be classified as one of these four, because we're not going to look at anything greater than 180. Okay, another few definitions are for complementary angles and supplementary angles. Complementary angles are two angles with a sum of 90. The two add up together to be 90. So if we know one angle, we can find the complement of the other, or the complement to be the other. And then supplementary angles are two angles with a sum of 180. And the reason that we would have a definition for complementary and supplementary, why they would even matter, is because in the real world, we create things with right angles, buildings, all sorts of things, and with straight lines. We connect things, roads, to come together as straight lines. So it would be important to be able to pull those things together, floors, anything like that, and find, okay, if we need to make a corner and we're filling something in that's this much, what's the remaining portion that you're filling in? Something like that. That's why 90 and 180 are the ones that we focus on. Just to give you the visual, this is a right angle. If this is the angle that we know, then the complement would be this other angle, and the same thing here. Let's say this is one angle, the supplement would be the other angle. You could look at it either way, but there'll be numbers. It's not just like a theoretical thing that we'll look at. All right. Okay, a few more notes. These are for parallel lines, so we have to identify a few things here. I have to change, let's go red, the colors here. I'm going to identify this line coming through the two as L3, and then the ones on top and bottom, L1 and L2. Just so that we can reference them. Now, all the notes that we're about to list, they only make sense if I put this in place, that L1 and L2 are parallel. You remember, parallel means they run the same distance apart from each other forever and ever in both directions. They will never intersect. And then L3 is called a transversal. So if you can imagine L1 and L2 being, L1 is maybe the third floor of a building and L2 is the second floor of a building. Sometimes pillars or building materials are put in on an angle through things, and so you can see this line potentially cutting through the floors of the building. And it's called a transversal when that happens, when you have parallel lines and then something cuts through. And we specifically look at these relationships because you can see all of these different angles that are created from these parallel lines and transversal. There are a lot of angles that are the same just because of the special relationship that they have. So we're going to go ahead and list all those named relationships. The first one is between angle 1 and angle 4. When I'm listing in front of the 1 and the 4, it looks kind of like a crooked L. It's intended to mean angle 1 and angle 4. So in the picture, you see that they're across from each other within the little pod, 1 and 4. These are called vertical angles. And those two have the same measure. The same can be said for a few other sets in here. So 1 and 4 is one example of vertical angles. What do you think another one is? 2 and 3 are opposite each other. Those are vertical angles, so they're the same separately. 5 and 8 are vertical angles, so they're the same. 6 and 7 vertical angles, so they're the same. Okay, the second named relationship, let's go orange, is between angle 3 and angle 6. I'm picking one example to give here. Angle 3 and angle 6. It's kind of a clunky name here. These are alternate interior angles. Alternate because they're on opposite sides of the transversal. Interior because they're between the parallel lines. And surprise, surprise, these two also have the same measure. There's one other example in this picture of alternate interior angles. Alternate opposite sides of transversal and interior between parallel lines. So 3 and 6 is one. The other would be 4 and 5. Opposite transversal, inside parallel lines. All right, the third named relationship we have is between angle 1 and angle 8. Angle 1, angle 8. This has the same feel as the previous named relationship. Alternate because they're on the alternate sides of the transversal. But exterior since they're on the outside of the parallel lines. Angles. And these also have the same measure. 1 and 8 is one example of alternate exterior angles. The other example would be 2 and 7. And then the last named relationship we have, let's go, this is between angle 1 and angle 5. And these are called corresponding angles. Angle 1 up here in the top pod, angle 5 in the bottom pod. They're in the same spot within each of the pods. So they're in corresponding positions, they're corresponding angles. Corresponding angles, and surprise, surprise, these also have the same measure. Again, 1 and 5 is one example of corresponding angles. Another would be 2 and 6. Those are equal. 3 and 7, those are equal. 4 and 8, those are equal. Now, what's important to remember moving forward if you're working with this type of relationship, parallel lines, transversal, isn't necessarily, okay, 1 and 4 are always the same. 3 and 6, always the same. It doesn't quite work that way because we could have labeled the angles however we wanted to. What's important to remember is the relationship between them. Vertical angles are the same. Angles across from each other are the same. Alternate interiors are the same. 3 and 6 are the same in this picture. 1 and 8 are the same from alternate exteriors and corresponding in the same positions in the pods. So you'll notice that there's a lot of similar a lot of same measurements throughout this picture. So let's just summarize, at least for this picture. Yeah, we can fit it down here. Okay, so let's focus on angle 1. What else do we know? There's angle 1. What else is equal to angle 1? Well, angle 4 definitely is because it's a vertical angle. What else? Angle 8 is also equal to it since it's an alternate exterior. And angle 5 is also equal to it since it's a corresponding angle. So all 4 of those have the same measure. We can do the same thing with the remaining angles. If we say, okay, we also have angle 2, 2 and 3 are the same because they're opposite each other. 2 and 7 are the same because they're alternate exteriors. And we can't name it with 8, but we know that, well, not 8, sorry. 2 and 6 are corresponding. There we go. So all 4 of those also have the same measure. So really in these types of relationships, if you know one angle, you can figure out the rest of them. If we know one of them, we can figure out, let's say we know number 1, We could figure out 2 because together they create a straight line of 180 degrees. And then once we have 1 and 2, well, there's lots of relationships that are this angles that have the same measure throughout the picture. So hold on to that through the practice problems. All right, so let's start to see, yeah, I think we can go ahead and do these as practice. So these first 3 problems, I have to draw in for the bottom one. Red. Okay, the first one and second one, you're finding complement and supplement. Remember, complement means they add up to 90, supplement, they add up to 180. And then find the angle measures, but I've got to draw this in. If we say that this angle right here is labeled as x, and this angle right here is 4x minus 6. It's a technicality that I have to put the degree symbol there. It's not an operation. It's not telling you to do anything specific. You're just figuring out what the 2 angle measures are, not just what x is. So go ahead and pause the video and attempt these 3 problems. Let's see if we're on the same page after you go through them. Okay, so let's go ahead and take a look. Complement and supplement on the first problem for an angle that is 38 degrees. The complement, I'm going to list it above. We'll just do it right here. Complement means they add up to 90. So something plus 38 is going to give us 90. How could we solve that? 90 minus 38 gives us our answer. So 90 minus 38, we get 52. So the complement is 52 degrees. Do the same thing with supplement. It's going to be something plus 38 to give you 180, which means 180 minus 38 gives us our supplement, which is 142 degrees. Now, I'm not asking you to ever write this line. This is enough. If work needs to be shown, it's helpful to see how you got there. Same process for the second problem, complement supplement of 81.2 degrees. Complement is going to be 90 minus the angle we have, which is 8.8 degrees. And supplement, 180 minus 81.2 gives us 98.8 degrees. So there's complement and supplement. Like I said, those 2 are useful because in the real world there are lots of straight lines and lots of right angles. That's why they would be helpful. Okay, the third problem, looking for angle measures. This one's definitely a little bit trickier, but we have enough information to be able to solve it. Ultimately, we know that the 2 angles are complementary because they create a right angle. We see at the bottom down here, the little box means it's creating a right angle. So if we know that the 2 add up to 90, well then let's just set it up that way. The first angle plus the second angle add up to be 90. Now, I've seen before students add in the parentheses in this line. That's fine if they're there. In the next line, they can just disappear. The only reason the parentheses have to be there is because this whole thing is an angle measure. And it's not going to change your work in any way. It's just a notation thing. So once we have this equation, all we have to do is solve. X plus 4x gives us 5x. Then we want the x by itself, so we add 6. Then divide by 5 to get x by itself. And we get, you can keep the fraction if you want to, if my math lab or an online homework system asks for that. You can keep the fraction or you can go with a decimal. The decimal is 19.2. So that's what x is. But the question is find the angle measures. Well, one of them is simply x. So this one right here is 19.2 degrees. You don't really need the degree symbol by the 19.2 since x already has degrees. Okay, how do you find the other one? 2 ways to get there. The first way is to plug what you know x is back into this expression. 4 times 19.2 minus 6 gives us 70.8. So the other angle is 70.8. But there's a quicker way to get there. And they're both pretty simple. But the other way you could get there is, again, remembering that these two are complementary. So if one of them is 19.2, subtract it from 90, and you'll get the other angle measure. Either way, you get the same thing. 70.8 is your second angle measure. Sometimes a question like this will only ask you to solve for x. Sometimes it'll ask for one angle measure, sometimes both. It just depends, but this is the general process. I wouldn't be surprised if you saw a problem at some point similar to this, but where it was a straight line. One angle being something, the other angle being another expression. Find the angle measures. In that case, the only difference would be that your outcome isn't 90. If it's a straight line, it's 180. And then you would go through and solve the same way. We don't see a lot of algebraic stuff in this course. This is where you'll see a tiny bit of it, but even this is not too complicated. All right. Then we have one more practice problem. In this picture, I'm telling you that angle 1 is 32 degrees. I want you to find the other angle measures. So go ahead, pause the video. We'll come back together in a minute. Okay, so let's see if we got the same thing. Angle 1 is already given to us, is 32. We are looking for the rest. Angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. Okay, so angle 1 is 32. In this picture, angle 1 and 4 are across from each other. So they are the same, which means 4 is also 32. 1 and 5 are in the same positions within each little quadrant, so they are the same. And then 1 and 8 are alternate exteriors, so this one's also 32. How do we find the others? Well, we know that, for example, angle 1 and 2 have to add up to be 180, so we'll say 180 minus 32 gives us our measure for angle 2. Didn't bring the calculator. 148, which is angle 2. And then we know that the others are going to be the same. Angle 2 and 3 are opposite each other. Angle 2 and 6 are in the same spots in the quadrants. And then 6 and 7 are opposite each other. However you want to find those other relationships. And let's add the degree symbol by each of them, since we want those to be degree measures. Any angle in this picture could have been given to you, and I just want to caution you that both pictures we saw had parallel lines like this, a transversal cutting one way or another. It is also just as possible for you to see parallel lines like this, and then a transversal, angles labeled 1, 2, 3, 4, 5, 6, 7, 8. Again, remembering 1 and 4, same, isn't always going to be the case. Its opposites are the same, and just use those other relationships to keep that in mind. All right, so this video was a quick intro into the beginning of geometry. As we progress through this chapter, things will get a little bit more hands-on. This is just where we kind of had to lay down the groundwork for what we're going to see for the rest of the chapter. I'll see you soon for another video.